Okay, well, welcome to lecture number 2 of Fish and Game's Climate College. My name is Whitney Albright. I'm with the Climate Science program here at Fish and Game. And my counterpart, Amber Paris, who is the climate change advisor to the director, was unfortunately unable to join us today, but she is tuning in from our San Diego office with a conference room full of staff. So on behalf of both Amber and myself, I want to say thank you for joining us today. We're so excited to see all of you and so happy to have your continued support. We actually have, I think, about 230 people registered at this point, even more than last month. And I think there are even a few more that have dropped in today here in person or on the phone. So we thank you to both our staff and to our partners for your support. We've got a great presentation lined up for you today, and I'm going to turn it over to Ellie Cohen here in just a few minutes. But before we get started, I wanted to go over just a few logistics about today and about the course in general, based on some questions that we've been receiving from our participants. And before I forget, and before I get into that, if you are in the room and have a cell phone, if you could please mute it at this time. Also, if you did not sign in on your way into the room, we will be passing around a clipboard. Make sure you go ahead and sign in when you get the chance. So first, we do have a Climate College website on our Fish and Game site where we have posted our course schedule and different reading materials. This is a screenshot of our homepage where we have kind of general introductory information for the course. And if you look over on the right-hand side at that panel over there, we have a list of some key links to certain pages. And at the top of that list is a link to our course schedule and materials page. So when you click on that, you get to our course schedule page, and you can go here to check out what we have in store for you for the upcoming months. This is also where we post PDFs of the lecture presentations, and this will be where we post recordings of the lectures as well. And when you're on this page, you'll also notice that the title to each lecture is a hyperlink, and these links will go to a PDF that has more detailed information about the lecture presentation. And I pulled up the PDF that's currently online for today's lecture, just to give you an idea of what they look like. They all look similar to this. So you have your date, time, location information, some registration instructions if you haven't already registered. We also have the... So also on those PDFs, you'll find a list of recommended readings from our speaker. We have things like a speaker biography on there. We also typically include links to different webinars that are related to the course topic in case you're interested in getting some additional information. So all of that is on the PDF, and we wanted to just make sure that you knew it's there and how to get to it, and that it can serve as a resource for you. Also to our DFG staff, we wanted to remind you that we have an online discussion forum. And here's a screenshot of the forum. It's our Climate and Sustainability Roundtable, and this is accessible via the intranet. And what we typically post here are different reports and articles related to climate change. We'll also post some webinar announcements. And just recently, and what we'll continue to do, is post some different comments and questions related to these Climate College presentations. And so as part of your course completion, we are asking that you visit the forum and that you post to it at least 3 times by the end of the course in May. And so we encourage you to go there, check it out, see what people are talking about, reply to a post, start your own thread, and really engage in this discussion about climate change with your colleagues. And then a final couple reminders for today. Everyone on the phone has been muted in order to eliminate any background noise for our recording. If you're on the phone and you have a question, and we do encourage questions, please type those into the chat box over on the right-hand side of the screen and submit those questions to our host. And we'll try to answer as many as possible today, and those that we aren't able to address, we will save and try to get those answered for you here in the near future. All right, now I'm going to turn it over to our Chief Deputy Director, Kevin Hunting, to introduce our guest speaker, and we're really happy to have Kevin here today. It's great to have such wonderful support from our executive leadership at Fish and Game for the Climate College. So Kevin, turn it over to you.
Thanks, Whitney. Appreciate it. And it's my pleasure to be here today. I was hoping someday I'd have an opportunity to introduce Ellie. I've known her for a long time, and I was at a conference this last summer, and one of the presentations I saw was on partnerships, and the presenter challenged us to kind of look across our partnership landscape for what we did and identifies those that really meet the high bar of good partnerships, shared risk and reward. And high levels of synergy, good outcomes, and one of the ones that came to my mind immediately was PRBO. We've had a long relationship with Point Reyes Bird Observatory and with Ellie, and I really appreciate her stepping up to do this course. So a little bit of background. She's the president and executive director of the Point Reyes Bird Observatory and has been since 1999. I got a bio for her, and there's a long list of professional activities and accomplishments, and I'm not going to read them all, Ellie. I'll just hit the highlights. Co-founded the Bay Area Climate Change Consortium, currently serves as the vice chair of the California Conservation Landscape Cooperative, which is another partnership we're involved in that I feel very strongly about. It's been a really good thing for the department. And is a member of the executive committee for the San Francisco Bay Joint Venture. So I'll leave it at that. It's my great pleasure to introduce my fellow advocate in bird conservation, Ellie Cohen.
Thank you very much. I appreciate it. Okay, great. Well, thank you all very much. Thank you, Kevin, and thank you, Whitney, and thank you, Amber, down in San Diego. It's really an honor and a pleasure to be here. So, you already heard a little bit about PRBO. We call ourselves today PRBO Conservation Science. We were founded as Point Reyes Bird Observatory. Today we have 140 staff and seasonal scientists that work all over California, the Pacific Flyway, on land and at sea, and as far away as Antarctica. Our mission is to advance conservation through bird and ecosystem studies and restoration and partnerships. And Fish and Game, and soon to be Fish and Wildlife, is a wonderful partner of ours as well. So thank you again. Our highest priority is to reduce the negative impacts of accelerating environmental change, and that ranges from habitat fragmentation, pollution, over-extraction of natural resources, invasives, loss of fresh water, population increases, and on top of all that is climate change. So today I'm going to speak about climate change, give you an overview and some of the latest findings globally and here in California, talk about climate-smart conservation, key principles and examples of how we can apply it in everything that we do, and some more about what we can do to make a difference. Should be, let's see. Yes. Are you not hearing it? You want me to move it up a little? Okay. How's that? Better? Okay. All right. This photograph is one of the first pictures we ever saw of our planet. So beautiful blue and teeming with life, taken in December of '68 by Bill Anders on Apollo 8. And seeing our planet from afar changed a lot of how people viewed what we need to do on our planet. When I look at this, I think about the history of the Earth. If you put the history of the Earth on a one-year timeline, the Earth was formed on New Year's Day. Multicellular organisms came into being midsummer. Dinosaurs around the beginning of December. Birds, Christmas Day. Early humans about 40 minutes before midnight on New Year's Eve. And the period of time when the huge glaciers retreated at the end of the Ice Age around 10,000 years ago, when agriculture was formed, science and language and writing and arts and music and all the things we associate with civilization and culture, all of that blossomed and came to being in that very last minute of time on that entire calendar. And during that last minute, because of human activities, we have completely altered the chemistry of the biosphere and changed the future of the planet for all of us, for all life on Earth. In the most simple terms, when the sun's radiation comes down to Earth, it warms the planet. Some of it stays in and some goes out. It's held in by greenhouse gases, and just like it says greenhouse, like sitting in a car in the summer, if the sun is beating down, it gets very hot very quickly if your windows aren't open. So in essence, these greenhouse gases, carbon dioxide, actually water vapor is a greenhouse gas, methane, nitrous oxide, and other gases hold in that heat and don't allow it to go back out. And they essentially form a blanket around the Earth. And what's happened by our insatiable appetite for fossil fuels, for oil, gas, for trees, knocking down forests and destroying soils all around the world, we have increased greenhouse gases in the atmosphere to the point that this blanket is growing and getting thicker and thicker. In fact, we now have more carbon dioxide in the atmosphere than we've had actually in the last 15 to 20 million years. This chart here shows carbon dioxide and temperature that is from ice cores from Antarctica. As snow would fall over hundreds of thousands of years, it would capture little pockets of air. So we actually can take those little air molecules and assess how much carbon dioxide was in the air at that time. And as you'll see, there's a natural variability over all these years. The high points are where we had warming periods, and a low point with less carbon dioxide in the atmosphere, we have ice ages. And you'll see here that today's concentration is way above the highest point, which was close to 300 parts per million. Today we're around 393 parts per million, way above that average. In fact, another study was done a couple years ago that showed that we are way above what has been until about 20 million years ago, when sea level was 75 to 100 feet higher, and temperatures were 5 to 10 degrees Fahrenheit higher, with this much carbon dioxide in the atmosphere. If we continue with business as usual, we will, by 2050, be over 600 parts per million. And what I'm going to do today is tell you about some of the things that are already happening just at this level of carbon dioxide concentration in the atmosphere. I do want to point out there are some people in Washington who think that because we had some heavy snowstorms in the past couple of winters, that means global warming doesn't exist. But in fact, the planet is getting warmer overall. It's about 1.5 degrees Fahrenheit warmer over the last 100 years, and it's projected to get anywhere from 3 or 4 degrees Fahrenheit to 11 or 12 degrees Fahrenheit warmer on average globally over the next 100 years. And if there is more water vapor in the atmosphere, which is one of the results of climate change, as the planet warms and ice melts, there's more evaporation, there's more water vapor in the atmosphere, and hence storms will be stronger. And if it is a precipitation event and it's below freezing, it will snow. So we will still have snow even if we have global warming. In fact, the decade just passed, 2000-2009, is the warmest decade on record. January to September this year is the warmest for January to September on record, which started in 1800, and it's the most extreme in the contiguous U.S. And July was the warmest month on record ever recorded. Ocean acidification is often put under the title of climate change, but in fact it's not directly related to climate, although a warming ocean has been shown recently to exacerbate acidification effects. Ocean acidification happens when carbon dioxide mixes with compounds in the water and in the ocean and forms carbonic acid, and it tends to break down calcium-shelled organisms, calcium bicarbonate. And so we've already seen in places like Puget Sound that the pH level, the acid level, is already increasing, and that oyster production, the young oysters, have been affected by it. And some predictions are that when we get below 7.7 pH right now, globally the average is around 8.1, but in some estuaries it's already been measured at 7.7. When we get to that average globally, that we will have shifts such as jellyfish being the dominant ocean organisms over these calcified organisms. Arctic sea ice extent this year is the lowest that it's ever been recorded on September 16, 2012, half the 1980 size, and there are projections by scientists who were very conservative about what was happening, who are now saying that summer ice could be gone by the end of the summer in just 3 or 4 years. Some of us might think maybe that doesn't matter. I'm never going to the Arctic. I'm not going to see that. But actually it matters a lot. Because as we lose that white reflective surface that sends those heat rays back out to space, we have darker surface remaining, the ocean. And that dark ocean absorbs more heat. And it becomes what we call a positive feedback loop, which is actually negative from our point of view because it accelerates the warming. So what's happening right now is that the ice on the Arctic is thinner than it's ever been. It's melting much faster, and it could well be gone by the end of the summer in a few years. In fact, all the projections, and this shows about almost 20 different models of projections for when the ice in the Arctic would be gone, we are way far ahead of it. It's happening much, much faster than projected, and the head of the National Snow and Ice Data Center said that the Arctic summer ice is in a death spiral and it's not going to recover. What does that mean for us? There are new studies, literally one that just came out a few days ago, that are now linking the warming of the Arctic waters to the extreme weather events that we're having in North America and in Europe, and actually throughout the entire mid-latitude. It destabilizes the jet stream and is causing it to wobble, essentially. And so we can expect to see even more of this as the Arctic gets warmer. In addition, with the warming waters, the permafrost is melting. And yet another new study that just came out in September. We almost have a perfect storm of studies now where we have the studies, the science is coming together with our actual in-the-field observations, and they're starting to mesh more and more and more. The science has been very behind what's actually happening out in the field, and now it's beginning to catch up. And the message is not great. I mean, obviously, with Arctic permafrost melting, what that means is that it's going to release more greenhouse gases, particularly methane, which is relatively short-lived compared to carbon dioxide, but quite a bit more powerful in holding in heat. And so it could have a dramatic impact. And this study projects that it will add another 1.5 degrees Fahrenheit warming over the next century. The ice sheets are melting faster. And I do want to point out that the ice sheets on land are, when they melt, that's what causes sea level to rise. The Arctic ice and ice sheets that are outside these fjords and glaciers, when they're sitting on the water and they melt, it's like an ice cube in a glass of water. It can melt it. It keeps the water level at the same height. But when that ice melts at the mouth of the fjords, for example, it's like taking a cork out of a bottle. And what can happen is the ice that's on land can flow off that more easily. It's more exposed to the warming waters. And it's partly what's happening here. In fact, in this part of Antarctica, and Pine Island Glacier, which is bigger than New York City, is melting into the sea at a rate of 2.5 miles a year, or about 35 feet a day. And this is happening in other places. In Greenland this year, they had an unprecedented surface ice melt. It's accelerating rapidly. And this is contributing significantly to sea level rise. The Intergovernmental Panel on Climate Change study that came out in 2007 actually projected a much lower rate of sea level rise than is actually happening because we didn't have the science yet to tell us how the melting of Greenland and Antarctica would actually accelerate the warming. That is finally coming now, and we're starting to know more and more about it. It's not just the Greenland and Antarctica, but also glaciers all over the world. And snowpack, like for us here in California. In the Himalayas, I know they are now seeing an accelerated rate of retreat of glaciers. And there you have 1.5 billion people dependent on fresh water from this glacier melt every year. It's true in South America, and it's true for us here in California. We are economically and ecologically dependent on the snow melt and that regular process each spring and summer. With all of that, sea level is expected to rise up to 6 feet globally by 2100. And there are some who project that because of what happened in paleo times, that we could see sea levels high as 5 meters, or about 16.5 feet this century. Mostly the science, like I said, has been behind what has actually happened. And it's one of the reasons why, one thing that I'll talk about with you in a little while, we need to consider other scenarios than what the science is telling us in the moment when we do planning for climate change. It's not just sea level rise, but we have to add to that high tides and storm surges in winter. This was a great graphic that was from the San Diego Union Tribune in 2007. And it shows what happens if you have 3 feet of sea level rise with a fairly typical 4-foot high tide and 10-foot wave surges in a winter storm. Suddenly you have 17 feet of flooding. So it's not just the sea level rise, it's what happens with waves and storm surges. And another study came out this summer showing that the expectation is we won't have big increases in wave height off the coast in California. It may happen further north in Oregon and Washington. But we are expecting that even with the sea level rise projected, that essentially there will be a once-in-a-100-year flood every year off of our coast. Extreme drought. The projections are, there was a study done by Dye from the National Center for Atmospheric Research showing a a synthesis of all the drought information around the world, all the drought studies. And it's actually an incredible study, and I highly recommend that you take a look at it. This was from a couple of years ago. It's proving to be true already, and it shows through different time frames, more uncertainty out into the future, high levels of drought. There's a measure here called the Palmer Drought Severity Index. If you remember the Sahel drought in the 1970s, that was between -3 and -4 and considered to be one of the most severe droughts in this century, in the 20th century. And already now, we are experiencing some of that, and it's projected to get much, much worse over the years ahead. In fact, this year, we saw epic drought across our country where about 2/3 of the United States was officially in drought, and comparable, or worse even, than the Dust Bowl era and the droughts of the 1950s. I do want to say that drought happens naturally in parts of the United States because of a cold phase in the Pacific Ocean. And from roughly 1970 to 2000, we were in a warm phase. And we have switched to a cold phase, Pacific Decadal Oscillation, which is partly what's driving the drought. But we have on top of that, extreme heat events, higher nighttime lows. And all of that together is driving this to be even more extreme. And that's what happens with these extreme events. It's on top of what natural processes might have already been happening and make it more extreme, not what we are accustomed to and what we have built our society around. This is a little hard to see, but I decided I want to include this map. This shows in August 20th, 2012, the smoke, the range of smoke from the forest fires all over, not just forest fires and grassland fires, all over North America. This year was a record wildfire season. The Forest Service just ran out of money from its firefighting program and now has to take from its forest management program to fight fires. That's something we talked about a few years ago as maybe that'll happen in 2030 or 2040. It happened this year. And I have on here the latest update through October 10th, that almost 50,000 fires burned this year with almost 9 million acres. Fire is a natural part of ecosystem function for us in the West. But we have millions of people who live amidst it now. And that wildlife-urban interface, wildfire-urban interface is going to be really challenging. What do we protect? Our houses? If it's my house, I might want that to happen. When I look at it from an ecological point of view, we need, even the hot-burning fires, there are species that are dependent on that. So some interesting challenges for us in resource management. 2012 is on track to break the 2011 record of extreme and deadly events. 2011, there were $55 billion of damage. This year, I think it was on March 2nd, there were over 80 tornadoes in one day, and tornado season supposedly doesn't start till April 1st. In March, 15,000 temperature records were broken, and we can be sure that they're going to break again. It's not the right question to ask if this storm or that is due to global warming or natural variability. Nowadays, it's a little bit of both. So climate change isn't real. It won't come soon. It won't be that bad. It's time that we pay attention to it. And fortunately, another study just came out last week that says a large and growing majority, 74% of Americans say global warming is affecting weather in the United States. It's the beginning of a sea change, I hope, where there'll be more support for really dealing directly with this issue. Biological diversity, there have been a number of studies this year that for the first time have shown what we all believe, that biodiversity drives ecosystem function and ecosystem health, but we now actually are starting to be able to demonstrate that. Some projections are that a quarter of all biodiversity will be lost even by 2050. Most of that will be in the tropics, but huge impact. What does that mean for ecosystems? Ecosystems that we rely on, whether we live in the middle of a big city or in the middle of the Amazon. Here in California, alpine species have nowhere to go. 9 out of 25 pika populations are already extinct. There are changes in phenology that are widespread. The black-headed grosbeak is one of over a dozen songbirds in Central California that are arriving earlier in the spring. Edith's Bay checker spot is extinct in the Jasper Ridge population, where the timing between its host plant and its caterpillar emerging were off, so that the host plant came, it dried up, the caterpillar came out, no food. And that is exacerbated by other environmental pressures like invasives and fragmented habitat. And then common murres at the National at the Farallon National Wildlife Refuge, where PRBO works in partnership with U.S. Fish and Wildlife Service, are breeding 20 days earlier. We don't know what all those impacts will be, but these ecological mismatches have challenges for species and for ecosystem function. At the Farallons, we studied 12 different seabird breeding species there. The Farallons, by the way, in case you don't know, are about 25 miles west of San Francisco, and it's the largest seabird breeding colony in continental United States with over 300,000 breeding seabirds. One of those is the Cassin's auklet, not a bird that most of us will even see in our lives. It's the size of a robin, and it turns out that the Cassin's auklet is a very good indicator about what's happening in the world around us. We have these long-term data sets which allow us to tease out both human-caused and natural change over time. This starts in 1972, and it shows the breeding success per pair. And you'll see sometimes it drops off here, and that's an El Nino year where there's less food, and then it goes back up. This shows from 72 to around 2000, that warmer period Pacific Decadal Oscillation I talked about. And then it started going up a little around 2000, 2001, 2002. We thought, well, we're moving into this cold phase. For us here in California, when the ocean's cold, it means more upwelling and more food and more rich resources off the coast. But then, it really wasn't the beginning of a cold PDO, or something else was happening, because in 2005 and 2006, we had complete breeding failure of Cassin's auklets. The signals were right to lay eggs. They laid their eggs, the chicks hatched, and then there was no food in the ocean. It was just all gone within a week, and the chicks died on the nest. And it happened 2 years in a row. Then, in 2010, we had the highest breeding success ever recorded. One of the predictions for the ocean and climate change is that we'll see more and more variability, these big swings from the worst of times to the best of times and back and forth. One of our questions is, if this happens on a more regular basis, what does it mean for this bird? And we did a study and saw that if this happens if it repeats over the next 20 years, even just once, it will have such an impact on the Cassin auklet population that it will decline by over 62%. The Cassin's auklets are dependent on krill. Does anybody know what else is dependent on krill when they're in the ocean? Salmon. Salmon. So it turns out that as the auklets go the salmon. And sure enough, this slide used to be just these headlines down here. Salmon season called off, 2008, 2009, 2010, after the 2005, 2006 happening with the auklets on the Farallon. And now we see them going way up, 2010, 2011, even this year, it's still up pretty high. What do we see with the salmon? They're making a comeback in Northern California. When you read it, on the news about it, you hear about it, they're all talking about all the great restoration efforts in the rivers, which are really an important part of their life cycle, but the vast majority of their life, they spend in the ocean. And so if there's no food in the ocean, we may not have salmon around. And we don't know whether this is the beginning of a new ecosystem state off our coast, but it sure seems like that's the direction that it's going in. We have also seen impacts of extreme heat events on breeding birds, on the Farallons and at Alcatraz. We've seen that in general, the system has become more erratic since 2005. And here's one last example I want to show you where Cassin's auklets and Brandt's cormorants paralleled each other in reproductive success over 30, 40 years. But then, since 2004, have gone completely different directions, and we thought that they were responding to conditions the exact same way. Something's changing. The anchovies are gone. One species is okay, the other's not. What's changing in the ecosystem? We don't know yet, but we do know that it's signaling a major change and possibly an early warning for what may be happening on land sooner than later. And finally, in this section, I just want to summarize that ecosystems are, you can think of a complex tapestry, and every species is one of the threads, and they've been woven together over millennia in careful, complex ways. And with climate change, very rapidly, in our lifetimes, in this decade, in this year, right today, these threads are unraveling. And then they're going to reweave into new combinations that we don't know what will happen. We know over geologic time scales, they'll be fine. But what does it mean for life as we know it? And one analysis we did from PRBO was to look at 200 different, or 199 bird species across California, their associations with vegetation, and using moderate climate scenarios from the Intergovernmental Panel on Climate Change. And we found that about 50% of California will have really different bird communities by 2070. And that's the moderate scenario, and we're exceeding the worst case scenario right now. So things are changing. Things are changing. Oh my gosh. They're not changing that much. This is a Photoshop picture, but to be sure everybody's awake after lunch. So business as usual. I got this cartoon a couple years ago, and now we've exceeded 7 billion, so let's put the correct number on there. We're running empty. Fossil fuels, wilderness, fisheries, water. And the bottom line is that we all rely on healthy ecosystems for our survival, whether it's food, fresh water, wood and fiber and fuel, climate regulation, flood regulation, disease and water quality, recreational, educational, and spiritual. And how many of us go out to a mountaintop or to the ocean and just to get rejuvenated? It's in our genes. We are attached to nature, and we are totally dependent on it for all these things. So what do? The good news is that we can reduce these impacts of climate change, and we can provide more time for people and for wildlife to adapt. But we have to start acting now in a big way. To prevent what I call climate chaos, which is what it seems like we're getting to, we have to engage in mitigation and adaptation together. So many of you have heard of AB 32, the landmark California law, which is considered by people all over the country and even all over the world as one of the most advanced laws addressing climate change. It doesn't address nature. It addresses mitigation. It addresses reducing greenhouse gas emissions. It does say to enhance carbon sinks also. And adaptation is just the very first law, I believe, in California that included adaptation, was just signed by the governor, that authorizes the Coastal Conservancy to actually act on climate change and support adaptation programs. I believe it's the very first one. If anybody knows otherwise, please correct me. Notice that in adaptation, what it means is to actions that reduce the risks of and help us adapt to climate change impacts on both the human environment and the natural environment. And what happens here is that natural environment always ends up being last. In any of the urban efforts, and even in the state efforts to address climate change impacts and what we're going to do, nature is last. But we need it equally there to really make a difference. So I keep thinking, just by having called it these two different names, mitigation and adaptation, which came from the scientific literature a long time ago, maybe we should come up with a new word and put it together, because we've got to think of both of them together all the time. We have to reduce greenhouse gas emissions, but we also need to figure out how to adapt simultaneously. So I thought about I can't even say it. Mid-adaption. How's that? But then I think a better word is just to say climate smart. Easier to say and easier to convey what it means. So here's my definition of climate smart conservation. It's conservation strategies and actions that specifically address impacts of climate change in concert with other threats. It promotes nature-based solutions by reducing greenhouse gas emissions, enhancing carbon sinks, reducing climate change impacts on wildlife and people, enhancing our ability to adapt, and sustaining vibrant and diverse ecosystems. Climate smart conservation. And so here's some key principles. There have been several groups that have developed climate smart conservation principles. It started a couple of years ago with the National Wildlife Federation. I was actually honored to be part of a group developing those principles, and Amber Paris was also part of that. And we were looking at focusing on what are the concepts that we need to think of that are different from how we do natural resource management today. What are we going to do differently? And I just boiled it down to 5. Focus on the future. We're not focusing on what it was like before. We're focusing on the future. An ecosystem context. It can't just be about single species. We have to look at entire watersheds, entire landscapes, entire systems. Adaptive, flexible management to address rapid change. We have to prioritize. We can't do everything. We have to prioritize based on the kind of outcomes that we want. And we need to collaborate and communicate across boundaries that we're not accustomed to. That's the best way for us to solve problems more quickly. So I'll go through each of these, and then I have some examples. focusing on future conditions, including these extremes, not the past. So let's imagine California over the last 100 years. We've had variability, but it's been, this is the worst flood we've had, and all of our levees are built through the flooding that happened up till 1950. But here's our future. It's all over the place. And what we need to do now is design not just restorations, but our management actions to address multiple scenarios. Worst case scenarios, moderately bad, and maybe some even that fall way down under here. It could be the 1,000-year flood. It could be the decades-plus drought or increased coastal salinity. We need to put these into our planning and think, what would we do differently, knowing that this is what's going to be happening. Even if it ends up not being as bad, we need to start planning this way. This is climate smart. We need to design actions in the ecosystem context, and that means thinking and linking beyond current protected areas, which is so much of how we've done successful conservation today. But we've got to link it to process, which means where's the water coming from? One good thing to be thinking about in California, where drought will probably be the biggest single impact that we'll feel from climate change over the next couple of decades. Plan for multiple species and benefits. And I like to think of it as the stool of life. Maybe that's not a good way of thinking of it. It's very rich. And so much of our conservation work has been focused on single species. We now need to think about it in the context of the whole biosphere, all of biodiversity, carbon process, water process. And if every project we do incorporates all of these, we will be giant steps forward in addressing the impacts of climate change. We need to employ adaptive, flexible management. And that is to address continual change. And you're all familiar with the concept of adaptive management, I'm sure. It hardly ever gets really implemented. In the context of climate change, where things are changing so quickly, and they're always changing, we have to implement some version of adaptive management. We have to do it. We have to identify and reassess the assumptions and future scenarios. We have to identify and reassess the threats and vulnerabilities and opportunities. We have to identify and prioritize our conservation and management options. Then we have to implement them. And with all that, we have to do the monitoring and the research and evaluation and adapt. We need to prioritize our actions for the best outcomes and for reduced vulnerability to the natural environment, but also the human-built environment for multiple ecosystem services, multiple benefits. And this is an example from San Francisco Bay, where we have done a tidal marsh and sea level rise study in partnership with the Coastal Conservancy and San Francisco Bay Joint Venture and others. And we've ranked restoration efforts based on how well they support birds today and well into the future at multiple timescales from 2010 to 2110 under high and low sea level rise scenarios, high and low sediment. For tidal marsh to grow and meet sea level rise and slow flooding down, it needs to have sediment. But there's not a lot of sediment out there. So we have to figure out, how do we get that? Some places have it more than others. So we looked at what are the areas that have the highest quality bird marsh habitat under these various scenarios, under all of them, and which ones then have the lowest quality habitat, so that managers can figure out, what do I need to do if I'm managing this place or that place? We need to collaborate and communicate across sectors and have actions on multiple time scales, multiple geographic scales, and long term, so that it lasts and is effective. You know that in California, half of California is public land, half private land. If we only focus on public land conservation, again, we're missing those ecosystem functions. So we need to work with scientists coming together with, here's a picture with rice growers. We need to work with kids so that they understand this and they can carry that on for the next generation. I have a couple examples of different kinds of climate smart actions. One here is climate smart rangeland management. A lot of times when we think about cattle grazing and rangelands, we think, well, that's not going to help us have better and healthier ecosystems, and it's not going to help us bring back water. But it turns out that we can actually do quite a bit by changing grazing practices. And so at PRBO, we are working with the Natural Resources Conservation Service to re-water some of these target major watersheds across Sacramento Valley and ultimately other parts of San Joaquin and the coast through prescriptive grazing and other eco-friendly practices in partnership with the Natural Resources Conservation Service. Our goal is to enhance 1.1 million acres over the next 5 years, and This is a conservative estimate. By doing that, it does have to rain, though. If it rains, we will restore water storage and flow in the soil equal to about 2 times Hetchy storage capacity and sequester over 1 million tons of soil carbon. We are hiring and training 21 partner biologists. We've already hired 4 of them. They're working with over 50 ranchers already. And they are based out of local NRCS offices, building relationships 1 rancher at a time, but looking at it and planning it from a whole watershed perspective. We're leveraging Farm Bill dollars and bringing them to California to enhance our conservation capacity. And it does work. This was done at Upper Stony Creek. It was re-watered through these practices, engaging 84 ranchers on 240,000 acres. These places that were ephemeral and only would run after heavy rainstorms, running year-round. First order and second order streams flowing year-round. Bringing back native vegetation, bringing back perennial grasses, which are critical. They have much deeper roots. They break up the soil. They allow the soil to be more porous, bring in the water, soak up carbon, and support biodiversity, and even helps the bottom line of the rancher. We have to be thinking in all new ways across these traditional boundaries. We have to work with the ranchers and other private landowners, with the public agencies together to figure out how we are going to bring back the water and bring and enhance biodiversity under these conditions. Another example, climate-smart riparian restoration. We know that riparian restoration is key to addressing climate change. Healthy riparian habitats reduce drought and flood impacts, recharge groundwater, provide connectivity, create refugia, and support all kinds of wildlife. We have, at PRBO, tried to figure out with partners in Marin County, what could we do differently that would make it be climate smart? So we started looking at the planting palette. What would we plant differently? So that if we have extreme drought one year and we have extreme flooding the next year, that the restoration is resilient to that and can actually continue beyond those extreme events. So we started looking at all these different species and planting more of them. Blue here shows our current palette, and the orange shows what we're testing now. So we're trying more plants that are sun tolerant, fire tolerant, flood tolerant. We're also looking at, let's provide more food sources. We know birds are coming 3 weeks earlier, 4 weeks earlier. Is there food source available 3 or 4 weeks earlier? Well, let's see if we can have food available longer for different periods of the year to provide that food source for migratory species, and especially to address these disrupted phenologies. And so nobody should read this, but what I want you to get from this is that every one of us can do this. This wasn't written in a book anywhere. It didn't come from a boss somewhere. It came from some staff on the ground thinking, what could we do differently? And so they analyzed every single plant here, looked at all these different conditions and ranked them. They analyzed when they produce food and when they produce cover during the year and put it all together, and we're trying it. And the first restoration 1 year later is looking really great. It's one little restoration, but our goal is to try this in many, many places and eventually to have a recipe, if you will, for how to do it, how to get going on it. Again, every one of you, every one of us can do this. And another example is climate smart planning. We talk a lot about vulnerability analyses. I need more information. I've heard this so many times from different managers. We need more information before I can do anything. I need more models. I need more projections. I need downscaled models so I can know exactly what's going to happen right here on my piece of land that I'm responsible for. We're never going to get all the information we need. We're never going to get all the money we need. So we have to think of new ways of kind of painting that tapestry that tells us what we might do in a changing world. And scenario planning helps us to do that. It's a collaborative tool for addressing climate change in an uncertain future. It's not about predictions. It's about assuming that futures will be very different, encouraging this out-of-the-box thinking with a group of stakeholders. It could be internal in an organization or external. It develops a range of plausible futures, worst to best case. It gets past paralysis by not having certainty in these projections, especially further into the future, and it guides what we need to do now to address this range of future scenarios. And really quickly, we did this internally at PRBO in a retreat recently with some of our staff looking at what might we do differently in the Delta. I have to tell you, I didn't ask them if I could share this with you all, but I am sharing it with you because we need to share. We need to share each other's learnings. And what we did was we followed a scenario planning process that goes from scoping, trend analysis, building scenarios, generating options, test options, and action plan. And you can find all that at this link here. And it's at this one, the link that I have right here is actually for businesses, but you can apply it to anything and everything. And we chose two main concepts that we would break up into groups in and assess. Fewer levees or more levees in the future, less fresh water or more fresh water. And our groups did two things. We built scenarios, and we started by brainstorming headlines. What will it be like in 2050? And it was with some basic assumptions that there will be sea level rise, and based on all the information I just presented to you. And we broke them into groups. We did headlines, and sometimes it's kind of funny because it's too scary to really think about it, so you come up with some really interesting headlines. But it really gets you into this other place. It gets you out of thinking, there's nothing I can do. And we even came up with names for our group. So I was in this group of less fresh water and more levees, which is worst case scenario from our point of view. And we were called the peripheral realities. Another group, pickleweed pastures. Another group, go with the flow. And what we found was that every group, after we came back together and generated options, came up with something that were the same. And those seem to be our no-regret options, ones that they work for the worst-case scenario and the best-case scenarios, things like optimization modeling. What can we do with these changes to get multiple benefits for biodiversity and fisheries? What kinds of things can we do to innovate restoration? How might we change what we do with levees? Can we make levees eco-friendly and structurally sound? We have to address this. In the valley, on the coast, we have to find ways. We're going to have more levees. How can we build them in a way that supports ecosystem function? It was an incredible exercise. You can do it. You can look this up. You can make it up for yourself. You can do it with your colleagues, with your staff. You can do it with partners. I'm just going to share with you really quickly other things that are working. People are designing and building tidal marsh levee systems in San Francisco Bay where they don't exist now. They're implementing managed retreat already. This is an example in Ventura where they're moving a parking lot that's already been damaged by storms and just taking it back. They're innovating tidal marsh restoration. The biggest limiting factor is sediment. They're creating hundreds of small islands that create these windbreaks and capture sediment so it'll grow faster than it would without that. Protecting food webs. We're identifying areas of high food web productivity even during El Nino years, even during the worst of times, so that we know this is the restaurant that the animals are going to when things are really bad. We need to make sure they are protected and that those resources are vibrant and sustained. We're giving species more time to adapt. So those species on the Farallones, on that really hot day back in May of 2008, some of them were in nest boxes that we built, and they became little ovens, a little mini greenhouse effect. So we did something very simple, built a little white top to put on top of it, and we tested it and made it 5 degrees cooler by having that on top. Just trying, experimenting, all kinds of things. And the last thing is focusing on collaborating across traditional boundaries. We have to be able to do that. The Bay Area Ecosystem Climate Change Consortium brings together scientists and managers. You have people sitting in academia and people sitting out in the ground, and they're not always talking to each other. We need to be talking to each other and informing one another. And of course, the California LCC is doing that on a larger scale all across the country. Couldn't be more important. We have to engage cross-boundary in ways that we never have before. And finally, with kids, engaging youth in the community and local hands-on restoration efforts. They are our leaders of tomorrow. So how do we address accelerating change on top of all these other stressors? We have to think out of the box and not be afraid to do it. We have to apply the 10% rule every day. Test and experiment now. This isn't just for resource management. It's wherever you work in your life, whatever you do, we have to do this to address climate change. We have to communicate the science and inspire hope. I think I can, I think I can. So I tell my kids, I think I can. And be solution-oriented, confident and hopeful, because people, they don't want to just hear the horrible things of the reality. You heard it. It's kind of a downer, that first half of the talk. If I only gave the first half of the talk, I don't think any of us would leave feeling I can do something. We have to couple the science with this possibility of solutions because they're there, because of human ingenuity. We know it's there. We just have to be creative and do it. And we do have choices. And just quickly for the scientists who are here today, We need to think about other ways of talking about what we do. When we say positive feedback, it sounds like a great thing, but we know positive feedback are deadly. And so a better choice is vicious cycle, self-reinforcing cycle, or uncertainty. People in the public think, oh, it's uncertain, then it's kind of, we don't really know, but it's actually a range of possibilities. And we can go on and on, but think about how to communicate so that more people can understand what we do. So no more business as usual. We have to be climate smart, reverse greenhouse gas emissions, enhance our ability to adapt, and make ecosystem conservation an equal priority now. There are those who think that we really need to be below 350 parts per million, and actually as of September, we are officially at 391 parts per million. Jim Hansen, who's the leading climatologist in the country, says that to preserve creation, the planet on which civilization developed, we need to reverse we not just shouldn't get to 450, we have to be at 350 or below. And he says that to do that, we can secure our future, but we'd have to phase out coal, we have to price carbon, we have to invest in energy efficiency and renewable energy, and secure nature's benefits. It is possible to do, but we have to act now to make this happen. And I want to show you, I want to close with this incredible film. So I'm not going to show you the film, but I took a few slides from this film called Climate, A Crisis Averted. Because of what these people did in 2012 and 2013 and 2014, this film was made in 2055 by Ken Burns III. Look at that. The only pollution from a car is water. Your personal pastel solar panel. Actually, I think they'll be much smaller than that. The Secretary of Climate is showing that CO2 levels off in 2026. Major investments in nature-based solutions pay off, water flowing despite drought and snowpack loss in August of 2050. That is possible if we do our work. And healthy urban environments. So in summary, climate change is happening now and accelerating. We can practice climate-smart conservation every day to reduce and reverse climate change impacts, to promote adaptation, sustain ecosystem benefits for wildlife and people. The principles of focusing on the future, designing it in an ecosystem watershed context, employing adaptive, flexible management, prioritizing across multiple scenarios for the greatest benefits, collaborating and communicating across sectors, and I will add a new one, follow that 10% rule. We really have to test and experiment now. We can't be afraid to. Again, your bosses aren't going to tell you to do it. You're not ever going to have the money to do it. But we together can solve this problem. We have to act now. Because of our climate-smart actions today, we will have healthy ecosystems sustaining wildlife in our communities for our children and children's children. Every one of us can make a difference. I don't know if you saw this ad in the San Diego airport back in February. How many light bulbs does it take to change an American? We really all can make a difference. I have lots of extra resources here for you. Thank you very much.